is 2025. For decades, one undeniable truth underpinned the entire global tech ecosystem, the undisputed dominance of a single, indispensable giant in cutting-edge chip manufacturing. Their fabs, their expertise, their sheer scale formed the bedrock of our digital world. Every smartphone in your pocket, every AI powering your future, every advanced defense system, all critically reliant on a seemingly irreplaceable lifeline. This wasn't just a business, it was a chokehold. A single point of vulnerability capable of crippling industries, halting innovation, and reshaping geopolitical power with a single decision. The prevailing wisdom dictated that without this titan, the future of advanced technology, well, it simply wouldn't exist. But what if that truth, that absolute certainty, just shattered? What if the digital world just experienced a seismic event that few saw coming? Prepare yourselves, because a new reality, forged in silicon, is about to send shockwaves across every continent. Welcome back to Revo Now, where we cut through the noise to bring you the stories that truly redefine our future. Today, we're dissecting a development that has already begun to ripple through the highest echelons of global power and the deepest trenches of the tech industry. For years, the global conversation around semiconductor manufacturing revolved around a painful truth. A vast, unavoidable reliance on a handful of specialized firms, primarily TSMC, for the most advanced microchips. Nations, particularly the US and its allies, have poured unprecedented resources into initiatives like the CHIPS Act, desperate to reduce their chip supply chain vulnerability and secure their own technological sovereignty. The idea of no TSMC, no problem was, until recently, dismissed as wishful thinking or even outright delusion. The complexity of manufacturing at the nanometer scale, the astronomical costs of EUV lithography, and the decades of accumulated intellectual property seem to create an insurmountable barrier. Yet, behind the public pronouncements and the frantic scramble for chip independence, something extraordinary was happening. A quiet, determined march towards self-reliance that has now culminated in a truly paradigm-shifting breakthrough. This isn't just about reducing a dependency, it's about fundamentally altering the power dynamics of the entire semiconductor industry. We're talking about a game-changing moment that will resonate for decades to come. To appreciate the sheer magnitude of what has transpired, we need to revisit the battleground. The global chip war. This isn't a metaphorical struggle, it's a very real strategic contest for dominance in the foundational technology of the 21st century. Faced with escalating export controls and restrictions on access to critical chip-making equipment, particularly advanced lithography machines from companies like ASML, one nation found itself under immense pressure. The intent was clear: to slow down, if not outright cripple, their ambitions in advanced chip manufacturing. For a long time, the prevailing narrative suggested that without access to EUV technology and the established global semiconductor supply chain, progress beyond certain nodes was simply impossible. Companies like Huawei, once at the forefront of telecommunications hardware and chip design, were directly impacted, facing severe limitations on their ability to source or produce high-end processors. The world watched, expecting a significant slowdown in their technological ascent, but sometimes immense pressure doesn't crush, it forges something stronger, more resilient. This relentless external pressure, instead of stifling innovation, appears to have catalyzed an unprecedented indigenous technological leap, a national imperative to achieve self-sufficiency, no matter the cost. While the global spotlight remained fixed on the giants, largely dismissing the capabilities of its underdog, SMIC, Semiconductor Manufacturing International Corporation, was on a relentless, often solitary quest. For years, SMIC was acknowledged as China's leading foundry, but always a few generations behind the bleeding edge. They perfected 14-nanometer technology, then surprised many by achieving 7-nanometer production for specific clients, reportedly doing so without the much-coveted EUV machines, utilizing instead complex and expensive DUV multi-patterning techniques. These achievements were often met with skepticism, sometimes even derision, outside of China. Many analysts maintained that truly advanced nodes like 5-nanometer, 3-nanometer, let alone the mythical 2-nanometer, were simply unattainable without direct access to the most sophisticated Western equipment. Yet, SMIC continued to invest, to research, to push boundaries. Their journey wasn't about simply catching up, it was about charting an independent course. This involves not just refining existing processes, but pioneering new materials, exploring novel transistor designs, and possibly even developing entirely new approaches to chip fabrication. The full details of their methodology remain shrouded in secrecy, but what's clear is that they have defied conventional wisdom. They've built an ecosystem of domestic suppliers and pushed the limits of their existing toolsets in ways few thought possible. And now, the result of that relentless, often unseen effort has just delivered a shockwave that will reverberate through every corner of the global tech landscape. Before we unravel the full, breathtaking implications of this monumental breakthrough, if you're finding this deep dive into the true cutting edge of technology and geopolitical power as compelling as we do, please hit that like button. Share this video with anyone who needs to understand the shifting global order, and subscribe to Revo now to ensure you never miss our urgent analyses. Your engagement is what fuels our ability to bring you these critical insights. For years, the 2-nanometer chip node has represented the absolute pinnacle of semiconductor innovation. It promises unprecedented transistor density, mind-boggling processing power, and radical improvements in energy efficiency. The holy grail for next-generation AI, advanced computing, and critical defense applications. Companies like TSMC and Samsung have been locked in a fierce, multi-billion-dollar race to master it, with their own mass production plans for 2-nanometer still in early stages or projected for the distant future. The challenges involved are immense, pushing the very limits of materials science, quantum mechanics, and manufacturing precision. It was seen as the ultimate hurdle, and the belief was that only those with access to the most advanced and expensive EUV machines could even attempt it. But then, the undeniable evidence began to emerge. Not through a boastful press conference, but through meticulous independent chip teardowns of newly released high-performance Chinese-designed processors. Analysts, initially disbelieving, confirmed the astonishing truth. SMIC is now producing chips at the 2-nanometer node. Let that sink in. This isn't theoretical. It's tangible, verifiable silicon. This isn't just closing the gap, it's a declaration of chip independence that fundamentally rewrites the script for global technology. It means that, against all odds, under the most severe restrictions, a nation has cultivated the indigenous capability to stand at the very forefront of advanced chip manufacturing. This 2-nanometer breakthrough isn't just a technical marvel, it's a geopolitical shockwave. The phrase, "no TSMC, no problem," has transitioned from a defiant ambition to a stark reality. First, the recalibration of global power dynamics is immense. The primary leverage held by the West in the chip war, control over access to cutting-edge silicon, has been drastically undermined. A nation capable of producing its own 2-nanometer chips can power its own hyperscale AI, its advanced military applications, its next-generation data centers, and its critical national infrastructure without any external dependency. This significantly diminishes the effectiveness of future export controls and sanctions aimed at stifling technological progress, fundamentally altering the calculus of international relations. Second, the economic landscape will splinter. While TSMC will undoubtedly retain its leadership in many segments and remain a crucial global player, the undeniable emergence of a fully independent, cutting-edge alternative introduces an entirely new dimension of competition. This will likely accelerate the trend towards fragmented supply chains, potentially leading to two distinct, yet equally advanced, global semiconductor ecosystems. For companies previously beholden to a single source, new options emerge, particularly for those operating within a vast domestic market now fully supplied with bleeding-edge components. Third, and perhaps most profoundly, this is the ultimate realization of technological sovereignty. It means a nation controls its own destiny in the most critical component of modern technology. Their semiconductor industry is no longer a strategic vulnerability, but a source of immense strength. This will unleash unparalleled advancements in artificial intelligence, quantum computing, and next-generation telecommunications within their borders, potentially setting new global standards and driving entirely new waves of digital innovation. The Great Wall of Cyber Independence isn't a metaphor for defense, it's now an offensive capability, ensuring complete digital autonomy. The shockwaves are just beginning to ripple through boardrooms and government ministries worldwide. Western leaders, who had largely underestimated or dismissed the pace of indigenous progress, are now undoubtedly scrambling to reassess their entire technology policy. Intelligence agencies are working overtime, dissecting the specifics of SMIC's process, attempting to understand exactly how this monumental leap was achieved without the previously considered indispensable tools. This breakthrough fundamentally challenges the very assumptions that underpinned years of strategic competition and technology containment. The immediate consequence for the West is a renewed and desperate urgency to accelerate their own domestic chip manufacturing capabilities. Billions, perhaps even trillions more will be poured into initiatives to build and scale domestic fabs, not just for diversification, but to directly compete at the absolute leading edge against a formidable, unexpected rival. The race for semiconductor leadership has just been redefined, becoming exponentially more intense and complex. Furthermore, this development forces a critical re-evaluation of the entire strategy of technology sanctions. If severe restrictions can, in fact, catalyze such unprecedented indigenous innovation, does it truly serve its intended purpose? Or does it inadvertently accelerate the very self-reliance it aimed to prevent, leading to a more bifurcated and potentially less globally interconnected technological future? The implications for intellectual property, global standards, and international collaboration are vast and yet to be fully understood. The era of singular reliance is undeniably over, replaced by a more dynamic and potentially more volatile global tech order. For years, the global tech narrative bred a certain complacency, a belief that control over certain key technologies, particularly EUV lithography, provided an insurmountable barrier, a perpetual advantage that could never truly be overcome from the outside. The no-problem mentality from the West was often rooted in the perceived impossibility of replicating such a complex, interconnected ecosystem. But the 2-nanometer shockwave from SMIC isn't just about a technical achievement, it's a profound lesson in the unexpected power of necessity and national will. The biggest reveal here isn't just that it could be done, but that it was done against the very strategies designed to prevent it. The real no-problem statement isn't from SMIC to TSMC, it's the stark realization for the rest of the world that their perceived technological dominance was built on a foundation far less stable than they imagined. The assumption of an indispensable bottleneck proved to be a self-fulfilling prophecy for self-reliance. This truly changes the game. The SMIC 2-nanometer breakthrough signals a new chapter in global technology and power. How do you see this seismic shift impacting your industry, your nation, or even your daily digital life? Were you surprised by this development, or did you anticipate an indigenous breakthrough under pressure? Share your insights, your theories, and your questions in the comments below. We're eager to hear your perspectives on these unfolding tech geopolitical shifts. And as always, if there are other critical areas of technological independence or future global tech trends you'd like us to dissect, let us know. Your ideas drive the future of Revo Now. Thank you for tuning into Revo Now. Stay informed, stay critical, and we'll see you in the next analysis.
Subscribe to Revo Now and join our vibrant community of forward thinkers, change makers, and revolutionaries.